Hello everyone, welcome to our COA presentation. Our presentation topic is execution of complete instruction. The topic is presented by Sunandan Kumbhar, Prajakta Kumbhare, Vibhor Kumbhare, Dhanraj Kumkar, Kshitij Kumare and Kunal Jadhav. Next slide will be explained by Sunandan Kumbhar.
Hello everyone, my name is Sunandan Kumbhar and now we will be discussing about our project in 4 points. So the points are introduction, instruction execution stages, detailed execution of complete instruction, flowchart. Now, instruction is command which is given by the user to the computer. Execution is the process by which the computer performs the instruction. Instruction execution means a program to be executed by processor consists of a set of instructions stored in memory.
Execution stages. First is fetch. In this fetch stage, instruction is being fetched from the memory. Second is decode. During the decode stage, we decode the instruction and fetch the source operand. Third is execute. During the execute stage, the computer performs the operation specified by the instruction. Fourth is memory. If there is any data that need to be accessed, it is done in the memory stage. Fifth one is write back. If we need to store the result in the destination location, it is done during the write back stage.
In step 1 the instruction is fetched. In the second step it is decoded and the instruction is read from the register files. In the third step ALU operations are performed, which basically means it is getting executed. In the fourth step the memory is accessed for either loading or storing the data in memory, and in the fifth step the result is written back in the registers and it again goes to the first step and so on as it continues in the loop. Now we'll come to the detailed execution of complete instruction. Consider the instruction add R3 R1 which adds the contents of a memory location pointed by R3 to register R1. Executing the instruction requires the following actions. First is fetching the instruction, second is fetching the first operand, third is performing the addition, fourth is loading the result into R1. Now the next slide is gonna be explained by Kshitij.
Control sequence for execution of this instruction is as follows: Pout, marin, read, select for, add, zin, zout, psin, yin, wmfc, mdrout, irin, r3out, mar.in, read, r1 out, yin, wmfc, mdrout, select y, add, zin, zout, r1 end. Instruction execution proceed as follows. The instruction fetch operation is initiated by loading content of PC into MAR and sending a read request to the memory. The select signal is set to select for, which causes the mux to select constant for. This value is added to the operand at input B PC content and the result is stored in Z. Second, update value in Z is moved to PC. Third, fetch instruction is moved into MDR and then to IR. Fourth, content of R3 are loaded into MAR and a memory read signal is issued. Fifth, content of R1 are transferred to Y to prepare for addition. Sixth, when read operation is completed, memory operand is available in MDR and the addition is performed. 7th, sum is stored in Z then transferred to R1. The end signal causes a new instruction fetch cycle to begin by returning to step 1.
Now let us understand the flowchart. Initially, the program counter PC is loaded with the address of the first instruction in the program and the signal counter is cleared to 0. contents of PC is loaded to MAR and read request is sent to memory. The value of constant is added to operand and the result is stored in Z. Now the fetch instruction is moved into the MDR, that is memory data register, and then to IR, that is instruction register. Then a memory read signal is initiated as contents of register R0 is loaded into MAR and contents of R1 is loaded to Y to perform operation. When read operation is done, instruction is sent to ALU, that is arithmetic logic unit, where operation takes place. Then the output of operation is stored in Z and then transferred to register. Then new instruction cycle begins. Thank you.